we are going to see the fourth subtopic of Unit 3, Water Resources and Human Health, Industry Settlement and Society, Impact, Adaptation in a Changing Climate. Coming to the climate change and water vulnerabilities, observational evidence and climate projections confirm that freshwater systems are among the most vulnerable resources impacted by climate change. So the most vulnerable when compared to other things is the freshwater. It is very well interconnected with the human. The freshwater mostly not only the human looking for the freshwater, even the other species, okay, wild animals, domestic animals, and birds, everything look for the water. Actually, they need to drink, right? So the most vulnerable part is the freshwater. This is affected because of the climate change. Okay, so observational evidence and climate projections confirm this. Impact include declining water quality, altered river flow, salinization, and water scarcity, threatening both humans as well as the ecosystem. So other species of animals belongs to the ecosystem. So the ecosystem is getting affected. Even not only the living beings, even non-living beings like tree. Okay, so this is depend. Okay, so just all depend on water. Global projections suggest that negative impact will outweigh benefits, especially in water stressed regions. Climate pressures are worsened by population growth, urbanization, and land use changes. Okay, worsened by the population growth, not only because of the climate, actually, think even because of the urbanization, population growth, and land use changes, climate pressures are worsened, okay, by these factors as well, which reduce the resilience. That means coming back to the normal position. Okay, climate, water, society linkage highlight the cross sectoral risk affecting the agriculture, health, industry, and settlements. Coming to the freshwater resources, not climatic drivers. Climate change impacts interact with human driven pressures, making it hard to separate causes. The key non climatic drivers include agricultural expansion and land use change, altering the catchments. Okay, most of the time the catchment area has been occupied in we see in the city side. Okay, and during the rainy season it is getting flooded. Okay, so this all is a unnecessary. We are creating an issue. The catchment area is by geographical nature is supposed to be a catchment area where the river, where the precipitation occurs, the water will be getting stored. If we go and do the construction in that particular catchment area, what will happen? Obviously, the where the precipitated rainfall will go. Okay, just imagine reservoir construction affecting natural flows, pollution emission from industries and urban sectors, groundwater overpumping exceeding research rate, human activity has intensified freshwater stress even before climate impact are fully felt. So, because of the human activity only, the intensified freshwater stress. That means that will leads to a uh, requirement. Okay, the freshwater stress in the sense we don't have enough water, fresh water. Okay, climate change acts as an amplifier, worsening the pre-existing water management issues globally. So we are not properly maintaining the freshwater requirement. Okay, and also now add on to that, the climate change amplify the things, so that will act as a multiplier. So declining water quality and groundwater stress, water quality deterioration is widely reported due to agricultural runoff, industrial effluent, and urban wastewater. So large quantity of wastewater is not treated properly before it has been discharged into the reservoirs, lakes, ponds, even the sea. Okay, so these all need to be taken care of by the human. Not only just solely depend on because of the human activities only this all climate change happens, and in addition to that, even to the climate change, the people have been doing all this without treating the wastewater they are letting out. This all will add on to that. So obviously that will leads to a high stress on the water management. Surface water shows increasing nutrient loads, sediments and pollutants affecting aquatic ecosystems. Groundwater levels are falling in many aquifers as extraction outpaces recharge, often unrelated to rainfall. Climate driven higher temperature amplify the climate reactions in water, increasing the contamination risk. Declining water quality undermines drinking supply, irrigation, and ecosystem health, raising treatment cost. Okay, coming to the lake, rivers, and aquatic changes. observed impact. Ecological shift. Climate warming has caused lakes and rivers to undergo ecological shift. Yearly fish migration patterns. Okay, because of this, what will happen? The climate change, the fish migration pattern happens. Species composition changes in aquatic ecosystem. Longer thermal stratification. So longer thermal stratification, let's say you have a river or even the sea have different layers of water. I mean, just until how we are measuring the troposphere, stratosphere in the atmosphere. Okay. Similarly, let's say you have a lake for certain depth, you will have a certain temperature. The water will have a certain temperature because it has been connected to the Earth's surface. Okay, obviously it will be little warmer when compared to the middle layer of the lake. When you go for the underneath the lake or underneath the sea, obviously it will be very cold. Where you will not find even a light is passing through it. Okay, so the species which has been living there will need to accommodate, or by natural means it will have the tendency that will live only in that particular depth. So longer thermal stratification leading to nutrient depletion of at surface and oxygen loss in deep layers. Okay, so imagine, so we know eutrophication because of the nitrogen, the plantation occurs. Okay, what will happen? The fish aquatic life could not able to survive and it will jump during the evening times to in order to for oxygen deficiency because of the oxygen deficiency that we have seen actually in environmental point of view, that eutrophication. Okay, you might have studied that one before. Okay, just imagine the longer thermal stratification means the thermal layer, the water layer has been having different temperature leading to nutrient depletion at the surface. So there would be any amount of nutrient at the surface of water and oxygen loss in deep layers. So there will be any oxygen at the very depth. So because of the, just imagine at the depth you don't have light and the pressure is very high, and because of the what you call even the submarine is not explored, improved. Okay, because of the pressure, high pressure at the bottom of the sea. So right now until 15 kilometers underneath the sea has been found so far. The exact depth is not been found still now. Okay, so imagine if it will go for 12 meters or 10 meter, 12 kilometers depth of the sea. Okay, the pressure is 1,000 times higher than the atmospheric pressure. Okay, so why we have been talking all about this? Because there is a depletion occurs at the surface. We should not change the characteristics of the nature. Okay, otherwise what will happen? It will have a negative impact on the human as well as the ecosystem as well as the to the planet. Water chemistry changes include rising sulfate, alkalinity and conductivity from catchment weathering. Okay, include rising sulfate. Okay, the sulfate value is increasing. Water chemistry changes include rising sulfate, alkalinity. Okay, so more than pH value is 7 and conductivity from catchment weathering. Glacial melt has transported toxic organochlorines is a persistent chemical compound because of the what you call pesticides, organochlorines and mercury into lakes. Glacial melt has transported because of the human made activities. This all has been transported. Okay, increase in the fish contamination. Okay, that means what you call the fish will take up this type of persistent compounds and it will be stored in their body. If you take the fish, what will automatically bio-augmentation takes place. Okay, so this changes threaten fisheries, biodiversity, even consumption, human consumption safety. Erosion, sedimentation and droughts. Human-driven land use change has increased soil erosion and river sedimentation. So when I was working in this down south of Tamil Nadu, Ramanathapuram, where I could be able to see the soil erosion. Okay, near to the seashore. Because of that, lot of what you call the coconut trees has been falling down because of the soil erosion. Not only but because of soil erosion, even water the along the seashore of the what you call the bay of the seashore. Okay, the coastal region of the seashore has been subject to a soil erosion because the trees are falling. Okay, so the coconut tree has been falling down because of the soil erosion. So they are asking for what you call remediation or overcome these issues. Okay, so these are the one of the problem statement as forth during the my last tenure. Okay, so just imagine this all happened because of the human made activities. Climate variability amplifies the erosion through intense rainfall and runoff shift. Drought occurs in multiple forms: meteorological, hydrological, agricultural, or ecological, reducing water supply. Excessive water withdrawals make droughts more damaging, especially in semi-arid regions. Okay, so when you have been going for underneath the earth, groundwater, just you will keep on taking, even there is no precipitation. It's a arid or semi-arid region. Just imagine. So if it is in very near to the coastal region, the salinity will come. The saline water will backflow. Okay, so otherwise what will happen? The groundwater level will be keep on decreasing, and even under 100 meters depth, you don't find any water. Okay, these are all the things because of the human activities. Droughts combined with poor water governance can lead to conflict, migration, and crop failures. Okay, and also not only human, it also added climate change. Climate change will intensify both flood and drought risk. Okay, the flood as well as drought risk because of the climate change will intensify. Human-made activities also do some activities. I mean, have a negative impact, and along with that, climate change will intensify both flood and drought risk, stressing adaptation systems. Projected impact: glacier and snow melt dependence. Just imagine, we have discussed this about the things. Okay, so the people, which region is been affected because of the glacier melt. Okay, so I don't want to touch upon this part. Projected changes in runoff and discharge. Higher latitudes and wet tropics may see 10 to 40% rise in runoff by mid-century. Okay, higher latitudes and wet tropics may have a high rainfall, high 10 to 40% rise in runoff by mid-century, around 2050. Dry mid-latitudes and top tropics would face 10 to 30% reduction, worsening desertification. So that it will become a desertification. So just imagine this. This is uncommon. This is not a common actually. This is going against the nature. Okay, because of the activities. Okay, so human-made activities. We need to control that part. Examples: Mediterranean Basin, Western USA, Southern Africa, and Northeastern Brazil are projected hotspots. So they are giving an identification actually where the rainfall will be flooded, will be more rainfall, and where will be become desertification. Okay, so just think of this should not happen. And water quality and deterioration: rising water temperatures and erratic flows will intensify the water pollution. Okay, and the risk include modern frequent algal blooms producing toxins, increased pathogen survival and spread. So imagine, okay, this all affect the human nature, human very immediately. Higher pollutant concentration due to reduced dilution capacity during low flows. Just imagine if the water is less. Okay, if you have been pulled, subject to, that means if you have been letting out the waste to the small quantity of water, the water itself could not able to regain its position, even it has been, despite it has been flow through for a longer distance. Okay, what will happen? Obviously the concentration of the water will increase, so the regaining capacities will be reduced. Okay, this all will causes the negative impact. More intense rainfall will transport sediments, nutrients and chemicals into the rivers. Okay, will transport sediments, nutrients and chemicals. So for example, if it is you have been using a fertilizers, okay, or not by what you call, not only contains nitrogen, phosphorus and potassium, it also includes some other compounds which are persistent in nature and toxic in nature. Okay, this through the runoff it will reach the underneath the earth as well as the surface runoff. When the people have been depending on the runoff, obviously they will be getting affected with different diseases. Okay, salinization from sea level rise will contaminate coastal aquifers and estuaries. This is all we have seen, right? Such deterioration threaten drinking water, agriculture, and aquatic ecosystems. Groundwater recharge and water reuse, precipitation variability. Okay, recharge rate are sensitive to precipitation variability. Decrease in humid areas with erratic rainfall. You could not able to predict the rainfall. Unusual rainfall. Sometimes it will fall. It will be more rainfall. Sometimes there won't be any rainfall. Erratic. You should not find out the pattern. Okay. So decrease in humid areas with erratic rainfall. Thawing permafrost alters groundwater flow in polar regions. Declining recharge leads to falling water tables, affecting rural drinking sources. Sustainable water reuse requires strict quality control and governance mechanism. Challenges in water management. Threshold challenge. Climate change worsens the threshold threefold challenge. Sorry, it's not threshold, threefold challenge. Too much water, floods. Too little water, scarcity. Too much population. Climate change worsens the threefold challenge. So the three fold challenges: flood, okay, too much water, too little water, and too much population. Okay, existing water management practices are often outdated and inadequate. National and international systems are poorly prepared for precipitation uncertainty and transboundary dispute. Developing nations face higher vulnerability due to limited infrastructure and weak governance. These all need to be taken care of. Adaptation. Efficiency improvements are essential to reduce demand. Recycling and reuse of treated wastewater. Water pricing and meeting to encourage conservation. Expansion of water market and virtual water trade between countries. Okay, so the water trade between countries, imagine expansion of water market and virtual water trade between countries. So, in the olden, I just would like to highlight about the Malaysia and Singapore. If you see, the people initially they just try to take the water from the rivers which have been flowing in the Malaysia. So after some time, they have some charges have been made. Okay, so obviously they want to be indigenous. So they did, they want to treat the wastewater for their drinking purpose, and they go for the desalination. Okay, from the seawater to potable water. So just imagine. So the virtual water trade between countries, expansion of water markets and virtual water trade between countries is an adaptation. Okay, so farmers can adapt water efficient irrigation techniques, drip, sprinkler, other what do you call it, clockwise drip irrigation. That's called drip irrigation. Urban areas must modernize distribution network to reduce leakage. Demand side measures are cost effective but need public awareness and enforcement. Adaptation and integrated water resource management. Integrated water resource management is a prevailing adaptation framework and is built for four principles. One is fresh water is a finite vulnerable resource. Management must be participatory. Women have a central role in water provision and safeguarding. Water has economic value and should be precised accordingly. Internal integrated water resource management strengthens resilience by aligning water, environment, and development policies. Policy integration and then governance and public participation in water management. Governance quality determines adaptation success. Public participation fosters awareness, acceptance, and accountability in water planning. Coordination among ministries, agencies, and local institutions is essential. Many countries suffer from fragmented governance. India's multiple water ministries, stronger institutions, and so there is a dispute. Most of the time, it's not easily dissolved. Okay, the problems is not easily dissolved, right? So, for example, the even though we have a central government, okay, the people between the ministries at the different state levels, okay, will not come to a common point. Okay, the interference of a central government will leads to something, but they will not accept the things what the things. So they will go for the court, and the things dispute is still prevailing, right, between the water dispute between the Karnataka and Tamil Nadu. So stronger institutions and legal frameworks that can reduce conflict and facilitate transboundary cooperation, empowering communities, building local resilience against flood, drought, and pollution. Human health. Coming to the human health. So, what for climate and water linkages? Human health depends on safe water and environment stability. Around 1.1 billion people lack access to safe drinking water. Underline the word 1.1 billion people lack access to safe drinking water, with the highest deficit in Asia and Sub-Saharan Africa. So, Asia and Africa, almost 1.1 billion people have been lacking of the fresh waters. 1.7 million deaths annually are linked to unsafe water and sanitation. Most of the diseases will spread because of the water issues. Okay, so water scarcity worsens the malnutrition, disease outbreak, and child mortality, child death, especially in poor regions. Okay, so they are highlighting the Africa as well as Asia. We are in Indian country. We are still saying is a developing country. How many people have lack of waters, of drinking waters? Okay, so we have been paying charging for drinking water. In the olden days, if you see some 30 years back, nobody will pay money for buying a water. Now just see this real scenario, how it looks like. So for 20 liters of water has been purchased with 40 rupees of for 40 rupees. I mean can water. Okay, even the people have been what do you call it, Chennai cities like urban areas. The people have been supplying water in through what do you call to trucks or what do you mean as to lorry. Okay, so these are the things how they are doing it. In fact, okay, the climate change and water-related diseases, diarrheal diseases may happen. Harmful algal blooms releasing toxins. Okay, heat promotes harmful algal blooms releasing toxins. Warmer leaks increase mercury level in fish. Okay, creating food chain risk. So these are all water-related diseases. Again, the people will be affected. Projected increases in cholera, schistosomiasis and malaria are tied to climate vulnerability. So just go and see what is somiasis. I think it's related to the skin disease. I think. Okay, just go and check. Okay, I'm not sure. And adaptation and health protection strategies, vulnerable groups, poor population with inadequate sanitation and water infrastructure. Health, health adaptation strategies include safe wastewater use for irrigation under strict guidelines, expanding drinking water and sanitation access to reduce mortality, climate proofing health service and early warning systems, integrated planning reduce risk of malnutrition, epidemics and child death. Impact on industry, settlement and society. What is the impact because of this all this climate change? Climate change threatens infrastructure and the urban water supply. Coastal cities and small islands face risk from sea level rise and storm surges. Energy sector vulnerabilities. Hydropower depends on flow variability. If there is no water flow, obviously the hydropower will be less, and obviously we could not. This affects the society. Okay, and then biofuels rise, land water competition, thermal and nuclear power face cooling water shortage, agriculture faces reduced water availability, affecting food security. So it's not the climate change is not only affecting the ecosystem or the human or water, especially what you call it, the sensitivity of certain things, agriculture and things like that. It also impact on the industry, settlement and society. That's what they mean. So in conclusion of today's lecture about the impact as well as the on the what you called different things, for example the society, okay, and industry settlement, society impact and adaptation in climate change. That's what we have been seeing here right now.